Hello everybody, my name is Olaf and I'm going to talk today about our usage of Solr at eBay Kleinanzeigen. eBay Kleinanzeigen is the classifieds site we run in Germany. So Kleinanzeigen simply is the word for classifieds in German. First of all, let me say thanks to the guys of Lucid Imagination. They brought me over here, so I'm happy about that and I enjoy a lot, so I hope you do as well. So who I am, as said before, my name is Olaf Zschiedrich. Our organization is part of the eBay Classifieds group, and I'm head of technology, so heading the development team of eBay Kleinanzeigen. Areas of interest, I have a passion for high traffic web applications, especially also agile development. We do work with Java EE, and I have a certain interest for search technologies. So let's have a quick look at the agenda. First of all, I want to give you some background about who we are, what we do. Then I'm going to show you some metric and traffic numbers regarding our site. I'm going to tell you why we choose Solr as our search backend. Then I want to demonstrate some of the features we're using live on our site. I'm gonna talk about how we index our data. We're gonna have a look at how we use Solr in production. I'm gonna give some best practices we discovered when using Solr, some problems we had when introducing Solr, and some outlook about our future plans. So who we are. So my organization is part of the eBay Classifieds group. We run several sites around the globe. So the latest we launched have been in 2009. So that was Germany, among others, and Italy and Spain. DBA, Bilbasen, these are sites in Denmark. Kijiji, you might know, there was a site in the US also called Kijiji. It now turned into ebayclassifieds.com, but Kijiji still is Canada's largest classified site. Gumtree is a classified site we run in UK and Australia, so it's UK's biggest classified site. Mobile.de, that's a car vertical we run in Germany. It's the biggest one in the market there. And Marktplaats is a site from Netherlands. Pretty huge site. Maybe everybody in the Netherlands has an account on Marktplaats. So overall, if you take everything together, eBay Classifieds Group is #1 classifieds company in the world. And now some background about our organization. So the platform we have is a typical classifieds ad site, so focusing on local trading. It's a vertical, has lots of categories. The site was launched in 2009, and it was kind of challenging because we had a very tough time frame. So we only had 4 months for developing the whole site from scratch. So it was rewritten from scratch. We do have a very small agile team. We use Scrum for the development process. So all over we are 12 to 15 people, including business units, marketing, SEO, and the development team, which is 5 to 7 people, so the largest part of the whole team is development. We leverage open source technologies a lot, so the whole platform is built on Tomcat, ActiveMQ, MySQL, Solr, and Spring. Applications we have, so of course we have the public website. Moreover, we have a customer support tool, so all ads coming into the platform, they go to a scoring system. We do some risk scoring, and based on the outcome, ads might be pre-screened by CS reps, or we send them live immediately. So that's the customer support tool. The API is kind of interesting, although we run several different sites across the globe that are developed locally. We came up with a common API that all our sites implement. It's a REST API and uses content negotiation to output JSON or XML. Cool thing about this kind of enables us to leverage apps we built especially for mobile devices across the globe. For example, the iPhone app of the US is basically, we forked it and adapted to the German market because it talks against the same API. We could reuses. And yeah, we have the iPhone app, as mentioned, was #1 free iPhone app in Germany last summer. And we also have a Facebook app that's a site integrated into Facebook. Basically, you can also browse classifieds ads, but you can also see like ads of friends and friends of friends. Also works against the common API. Some metrics and traffic numbers. So currently we do have about 3.2 million active ads. We serve about 16 to 24 million page views per day. And during peak traffic time, it's about 1.8 million page views, which means like 500 page views a second. Solr requests are a bit more because we use Solr backend heavily. Sometimes even during one request, we do multiple Solr requests. So we have about 60 million Solr requests per day. And during peak hours, our Solr servers serve around 1,500 requests per second. Speed of Solr backend is pretty good. So an average time for a search is 20 milliseconds. And we do use auto-suggestions and auto-completion, and the time for this is just 3 milliseconds. Luckily, site is rapidly growing. So when we launched site in 2009, we took over the content from Kijiji, which was also running in Germany before. So we migrated all the Kijiji ads to our new platform that have been 750,000 ads. And now, just 2 years later, we have about 3.2 million ads. So it's growing pretty fast. So why we choose Solr as our search backend? First of all, it's open source. I'm a big believer in open source. One main argument for me is that I do not want to run into a vendor lock, having kind of a paid kind of thing, company might blow up or whatsoever, and you're stuck with some kind of dedicated vendor, and it's hard to migrate off again. Solr has good documentation, and has good community, large community. Whenever you have a problem, you can look into the forum, you might find an answer. That was very important for us. It's Java-based, so our core development is also done in Java. So my development team knows how to deal with Java, which makes things easy. For example, if we want to extend Solr or debug Solr, we can use the same tools we use anyway. It's based on Lucene, which by that time was already the de facto standard for full-text search in Java, and it was pretty stable. Solr is feature-rich because due to the given time frame we had of just 4 months, we wanted to have something that really enables us to use a lot of features out of the box, from faceting, stemming, whatsoever. So we almost use a lot of the built-in features of Solr. It's easy to extend, it's easy to integrate, which I also like a lot. Protocol is based on HTTP, and it has a Solr J client, which makes it easy to integrate into Java applications. And finally, it's easy to set up. So basically, Solr comes as a WAR file. You can throw it into any kind of servlet container, Tomcat, Jetty, and it will run. So here's a list of the features we use. We use faceting a lot for faceted navigation, which is especially good for users that come to the site and do not exactly know what they are looking for. So mainly they come by, they're just looking for cheap stuff in their neighborhood. So faceting is a very good way to explore that content. Language-specific stemming is really important, so it should not matter whether you search something as a noun or as a verb or in singular or in plural. We use the auto-suggest, or we build an own auto-suggest feature based on the term component, which works pretty well. We do use spell checking, so if somebody types something wrong, you might get a suggestion about the right word. Synonyms is another story. To be honest, I really want to use it more. It's kind of a problem due to that we are a very small team, and synonyms kind of have to be actively maintained. And especially if you are a vertical serving lots of category, it's hard to define all the synonyms for different categories you have. So normally I would say there must be some kind of dedicated person, but as we are small currently, we do not have it. We use it a bit, but far too less, I would say. We use stop words to keep the index small, although I learned from Mark Krellenstein, it might not be the most clever thing to do anymore, so probably I rethink it a bit. And another great feature of Solr that I also like a lot is dynamic fields. Dynamic fields basically allow you to add new fields to the collection or the document schema without changing the schema. This is very important for us because we have kind of a flexible attribute system in our application. So we want to be able to add attributes to certain category, like brand of cars, for example, without the need of recompiling or re-rolling the software. So in our attribute system, we can just in the file system, we can configure new attributes and they immediately show up in the post item flow as well as in the search and as well in the faceted navigation of the site without any code changes. So let's have a look at some of the features I just talked about. Okay, let's just start by hitting a search. So on the left side, you see the typical faceted navigation with the numbers of hits behind it. You can browse into, this is family, child, and babies. For example, what can we have a look at? Baby clothing. And here, for example, it's different. Baby clothes, I think in the US, it's kind of sorted by age, 2, 3, 4. In Germany, we have numbers for this. For example, now you can say, hey, my kid has size 68. Show me all items that have size 68. And you can see also the district in Berlin where the item is. You can also do a distance search to find the stuff that is closest by. Yeah, that's basically faceted search. Here at the bottom, you can also see the sub-districts of Berlin, so you can really drill down even to the zip code level to navigate the site. Auto-suggest, let's see. Because we made it category dependent, so let me switch to all categories, all the car categories. So this is a search for BMW, you hit it, and then now it didn't find any items in Berlin, but we do kind of a zoom out, so whenever we do not find anything close by, we zoom out, so it finds one item for that BMW search I run, well, 150 kilometers away from Berlin. But maybe if you're looking for a car, it's worth traveling. We do use these kind of auto-completion a bit more also for sites for the bot. For example, we do have a site that is mainly for the Google crawler. We feed we feed all our searches into a Hadoop cluster and calculating the most popular searches over and over. And for this site, we then take the most popular words people are looking for and use the auto-suggestion to generate more content for the crawler, which is good. So it's based on alphabetically. What else? Let's have a look for similar items. So I was running a search for BMW. Let's run a BMW search in Berlin again. Okay, and if you go down the search, we have something that might be also of interest for you, so we show different BMWs. On top, you can even expand and see more of them. What we do here for more like this is also we use the scoring of Solr. So kind of we weight location a little bit more, and I rather prefer showing something less similar out of the neighborhood than, as said before, for cars it might work, but if you're looking for baby shoes or whatsoever, it doesn't make sense to show an item from Munich if you are searching in Berlin. So then we kind of use the location and score as higher. and probably show less similar stuff, but out of the neighborhood. Another feature we do use is spell checking. For example, if you type iPhone wrong, let me try something different. So I'm searching for a house now and type it wrong. Probably they changed it without telling me. I would have expected some spell check suggestions, but maybe due to Google AdSense and making some revenue, they kicked it out here. Anyway, last thing probably is synonyms, for example. This is a search I run for TVs, so Fernseher is the German word for TV. Another more or less funny word, but that joke doesn't work in the US that well, but the Austrians, they have a funny word which is called Patschenkino. So I created a synonym for it. You can also search for Patschenkino and it will find TVs as well. So that's the synonym feature of Solr. So data indexing. How do we index our data? Solr has a component called the data import handler, which has an implementation that allows you to import data from relational databases. We do use that. So we have a dedicated MySQL slave that we use for indexing data into Solr. What the data import handler does, it basically polls in a certain kind of rhythm you can configure, and it polls the latest changes out of your database and feeds it into the index. The master doesn't get any traffic, so it's only used for indexing, and then we use the replication handler, which is another built-in feature of Solr, to distribute the index to the slaves, and the slaves actually are the nodes that serve the traffic. The replication handler is, there's one thing to watch out. So at the beginning, so we index every 10 minutes, and at the beginning, after every indexing round, we did an optimize on the index. What an optimize does, it compresses the index again, throws out old content. The problem with that is if you optimize, then the slaves need to fetch the whole index again. So based on index size, it could be several gigabytes. If you have lots of slaves in your data center and they are all fetching a giant index at the same time, watch out to not overwhelm your internal network. That was something we did. So what we do now is we do not optimize every 10 minutes, which makes no sense. So we optimize once a night to keep the index fast. How we run Solr in production. So we are running 2 data centers, one in Frankfurt and one is in Amsterdam, and we distribute traffic across the 2 data centers. One thing we do is we always guarantee 50% overcapacity per data center. So in case one data center goes down, the remaining one has to be able to serve full traffic peak time. Per data center, we have 1 Solr master and 6 slaves. Currently, the slaves, they do show really not that much resource consumption, and we could go down even to 4 Solr slaves, still having 50% overcapacity, and the 4 slaves could be able to handle full traffic. As said before, we only use the master for indexing, so no traffic on the master. We do have load balancers in front of the slaves that distribute the searches across the slaves. Another thing we do is we put a varnish cache in front of the slaves. So for certain dedicated use cases, we cache even so that the request doesn't hit the slaves. For example, this auto-completion stuff, this is, by the way, a separated Solr core that we do not update every 10 minutes, but probably every 6 hours or 12 hours. And we cache it with the varnish. The varnish has another cool feature. It can kind of control backends. So at a certain time, we had some problems with long-running garbage collection, which would mean that then requests get stuck in the slave in case they hit it. So what we do now, we have varnish in front, and whenever a backend takes longer than a certain time, we reroute the request to another slave, take out that slave for a certain amount of time by the varnish, and then bring it back to load balancing in case, hopefully, garbage collection is gone. Well, we spent some time on garbage collection, so we do not have that problem anymore, but it's a nice feature. You can use the varnish to kind of mitigate long-running garbage collections in your backend servers. We do work very closely with our site operations team, so I'm a bigger fan of the DevOps movement. So normally, like, one of the ops is part of our ongoing projects, and we work very closely together with them. And the same site ops team runs the German car site, mobile.de, which allows us to kind of reuse all the monitoring tools, deployment infrastructure we have. This is a new slide I just added 2 days ago. So since last week, we are on Solr 3.1, which is the latest version. I think it came out 1 month ago. So we took the risk and migrated to the latest version. So there are some learnings. It's not plug and play. Main reason is that the index format of Lucene changed. So one advice they give is to first update your slaves because they are still able to read the old index format. We kind of choose a different approach. So we set up a separate master-slave cluster and just redirected the traffic of some dedicated web application server to these nodes, while the rest of the server farm was still served by the old Solr. Another thing is that the Java bin format has changed, so whenever you use the Solr J client for integration, you need to update the library in the client applications. Old one will not work anymore. And we faced 2 really major problems. The first one was really bad. There's a known bug. Took us a while till I found that bug in the ticketing system of Solr. It's a bug in the spell checker. If you use the collate feature of the spell checker and the search request has a lot of mistyped words, this leads to an infinity loop of BC. So with one request, you can immediately kill the whole Solr node. It was kind of, we did load and performance testing before, but we didn't discover this case. Then we brought machines to production and randomly they just crashed till I found that in the ticketing system, and I was kind of, could reproduce it by just hitting one request. I was able to kill the whole Solr instance. There's a patch attached to that ticket, so we patched the Solr, and since that it's working stable. Another bug that can cause trouble is there's a bug in the replication handler. If you use the replicate after startup feature, that leads to that old index files on the master are not removed, which could lead to disk problems after a while because it just grows endless and one time you might run out of disk space. Can simply be avoided at the moment if you do not use the replicate after startup feature. So the replication handler, the way how we use it anyway, polls the master every 10 seconds for a new index. So we just took out that option, so with the first poll it will get the latest index and then it works. Some best practices we follow. Use Solr cores. So we started out with Solr, I think it was even a nightly build we took out of the SVN before 1.4 was out. And we started with just a single index, so we didn't use the Solr core feature. The core feature is a feature that allows you to have multiple collection and multiple schemas, and you can either run them. So it's very practical because even if you just start with one index, one day you discover, hey, you need another index because you need to index other data. So if you start really right from the beginning, even with one index, use a core, and then it's easy to add another cores. Meanwhile, we have, I think, 4 different cores. We have one serving the active ads, which only contains active ads. We have one serving the API, which contains all ads because API and integrating partners, they also need to get delete events in order to update their content. We have one separate core for the auto-suggestion feature we implemented. And we just recently have a new core for our customer support pool because this indexes completely different data, including flagging and which CS rep worked on which ad and stuff like this. The nice thing is, in development, you can simply run all those indexes in one JVM, and in production, you can like run them on individual machines. Use filter queries, probably not that surprising. At the beginning, we used the plugin for distance search, local Solr, which was not working correctly for distance with filter queries. So at the beginning, we more or less had one huge query, like an SQL query, but it's not the way to go. Take some time to tune your caches, really look into Solr, and you should look at the statistics of your field, query caches, and try to tweak them. JVM tuning took us some time. We faced some garbage collection issues, so now we really took time to tune the concurrent mark sweep garbage collection. Now it's working pretty stable and pretty good, so we do not have any long-running garbage collections anymore. But took us some time. Then what we did, we built a search layer which kind of hides the users of Solr. I think it's nothing new. It's like if you access a database, you have a DAO or a repository layer, like hiding the usage of SQL, because you never know what comes. Maybe one day there's another search engine you might want to use. The way how we use this is basically you create a search command, then you can set the stuff you're looking for, set keywords or set categories, set location, all that stuff. You pass the command into the search service, and what you get back already is a list of our entity domain objects. So it's completely hidden Solr and the translation between the results that come out of Solr. So what the search actually returns are our entity objects. Moreover, we created a very, very simple query builder which uses a Fluent interface. Nothing spectacular. Basically, internally it's a string builder, and this kind of allows any developer to create a Solr query without the need to know the syntax of Lucene or Solr queries. So here at the bottom, you can see how you can use that query builder. You basically say free text and or in less than, greater than, equals, range, and stuff like this. And at the end, you say query builder build, and actually the build method returns the actual Solr query. Problems we faced, big problem was distance search, which especially for a site that focuses on local trading, it's important. We started using the Solr local or local Solr plugin, and that really caused a lot of trouble. First of all, at the end, it was not really working anymore with 1.4 and 1.4.1 final, which kind of blocked us from moving to newer Solr versions. And at the beginning, it worked fine, but as site was growing, we got more traffic. That plugin was really causing a lot of performance and garbage collection issues. So we had a time where we had like 12 or 14 slaves per data center instead of 6 or 4 we use now to serve the searches, even with less traffic. And mainly all of them were caused by the local Solr plugin. So after we took it out, mainly all problems went away. Solution we used was basically we got rid of one requirement, which is sort by distance, and the rest is easy. So basically what I do in Java, I calculate a bounding box, run a simple range query around alomng, and then on Java side again, calculate the distance of the actual item to display it. Nothing special, that works pretty well. As far as I know, this should be solved now in 3.1, so I'm definitely gonna have a look whether that works. Another problem is real-time updates, especially for our customer support tool. CS agents want to get updates as quick as possible. Currently, Solr does not really support real-time updates, so kind of all you can do is become as near real-time as possible, which can be quite fast, but like some CS reps, they tend to change something and hit search again, and they expect immediately to see the changes, which is a tough requirement. Hopefully it will be added one day. And another known issue, which is not that nice, is paging large result sets. So Solr tend to get very, very slow if you have huge result sets. So for example, you run a search without any criteria, it gives you 3 million items, and then you go to page 250,000, it takes long, long time. Which kind of causes some problems, especially when Googlebot is coming and crawling the whole site. It can really cause some impact. I think I saw that that is scheduled for Solr 3.2, so I hope there will be some progress in this area. Okay, future plans. So one of our plans is to migrate further applications to Solr. So currently some of our batch jobs and backend applications, they're still searching against database, as well as the customer support tool. We're gonna launch a beta version next week, where the customer support tool is also able to search against Solr. Currently, we, like CS reps, they just can choose whether they want to use the old search or the new beta search, but the plan is to get rid of the database search and then move completely to search against Solr. Yeah, and as we just recently moved to the latest version, there are some nice features that we're gonna have a look at. This is like a spatial and distance search I told you about. I think there's even a new index type where you can index lat long in one field. They have a dedicated auto-suggest component now, which is interesting. So our auto-completion is built on the term component. So I'm definitely gonna have a look and see what advantages this new component has. There's a new Dismax query parser, I think contributed by Lucid. It's the extended Dismax parser. We already use it in the new index we have for our customer support tool. Yeah. And probably another thing we might add in hopefully near future is, as site is really growing fast, I think one day the day will come where we need to think about charting. So currently we keep everything in one index, in one machine, JVM, which still works very good. But as we are growing rapidly, I think one day we're gonna chart. Probably by region is the most obvious. If you do local classifieds, have a chart for Berlin, have a chart for Hamburg and stuff like this. Questions. The question was like the way how we implemented our dynamic attribute system and how we use Solr for that. So basically, we configure the attributes on the file system. So you can say this is a list of brands for cars. This is I don't know, shoe sizes. And kind of the trick is with dynamic fields, you can have, for example, an underscore I saying this is an integer, underscore S, this is a string, and kind of that's the way how we configure it. So we configure the attribute system and also tell Solr what type of attribute it is. And we also can configure in the file system whether this is a simple facet on a field or whether this is a facet that is a range facet. And then, yeah, basically that's it. You configure it in the file system. We immediately, the attributes got visible in the post-add flow, and as soon as the new data comes in, it's stored in database. The Solr delta import handler picks it up from database, and Solr knows, hey, this is an attribute, it's of type dep, and it immediately adds a dynamic field. So the question is regarding the migration to latest Solr version, whether we needed to re-index the data. The answer simple is yes, because Lucene index format changed, so we were forced to re-index the whole data. Normally, we only do a full import in case, like, I don't know, the index blows up. Normally, we never do it. We do a delta import every 10 minutes and try to avoid full indexes. But anyway, we can do it from time to time. It's needed because, for example, you add a new mandatory field, then anyway, you have to do a full index. But especially for upgrading, yes. Yes? Okay. Thanks a lot.